Okay, the first type of polar graph we're going to look at is circles. So the form that you can expect to see a circle in for polar graphs, there's two different ones, r equals a cosine of theta or r equals a sine of theta. I drew out here what the two different scenarios are. If it's r equals a cosine of theta, remember in both situations a is the diameter of the circle. But if it's cosine, it's on the x-axis, and the leftmost edge is at what we call the pole. If it's r equals a sine of theta, again, where a is the diameter of the circle, this time it's on the y-axis, and your bottommost edge is at the pole. Your distance a, that's your diameter, is here. Your distance a back here, there is the distance for the cosine. So for each of these, I'm going to give you the form, do an example. For this one, I have a little bit of an extra bit I want to show you about if you were to convert the equation, just as like an FYI. So if this was the equation we're looking at, again, for the assessment for this unit, you'd have to recognize the different forms and how you were to graph it. I'm also later going to show you graphing calculator business. So here we go. We sketch r equals 4 sine of theta. So you can choose to make a table that I have, but there are some other things that are worth mentioning just to understand these graphs. Remember, important points on a graph are always the 0 and the max and the min values. So remember, to find a 0 or an intercept, you're putting 0 in for your y value. So here's your 0 in for r. And so we need to solve this for your theta. Okay, so that just means 0 equals sine of theta if I divide it by 4. So technically you'd take the sine inverse of both sides, but you're looking for the theta whose sine is 0. And in this case, your theta equals 0. And this time I'm in radians. Okay, my max. Well, how did I come up with this? Well, this is your equation, and why did I put 4 in for r? Well, the largest number that sine of theta could actually be is 1. So if this was 1, 1 times 4 is 4. Some of you could figure this out without the equation, but some people sometimes like it, so I do show it. So I'm really dividing by 4. I get 1 equals sine of theta. So you take the sine inverse of both sides. I'm looking for the angle that gives me a sine of 1. In this case, it is pi over 2. So this is really the point for pi over 2. I should have written this one out when I did it. 0, 0. I'll backtrack. Now the min, how did I come up with 0 here for my r? The smallest for your min there that we could have is at, I'm thinking -1. I didn't write that in right, did I? So our min is at -1. I'm going to fix that. So if sine of theta was -1, -1 times 4, this should be -4. Whoops, no problem. So that means if I divide both sides by 4, I'm going to get sine of theta equals -1. So I'm looking for what angle gives me a sine of -1, and I hope you're going to tell me 3 pi over 2. So what was my r in this case? -4, and my theta is 3 pi over 2. So you don't have to show the 0, the max, and the min every time, but I think it's important that you understand where they come from. I'm pretty much okay if this was like we were in class and, you know, we weren't taking assessments at home where we have access to the internet and books and friends and things like that. Usually what we ask for is a table similar to this. Okay. But again, I think it's important you understand these values here. So for theta, when theta was 0, we already have that answer. It was 0. For pi over 2, we already have that answer. We did it down there. It was 4. For pi, you can just put that into the equation. You have sine of pi is going to be 0 times 4 is 0. 3 pi over 2, we already figured that out. that's -4 for your r. And then 2 pi is going to be back at 0. So some of you are like, well, why can't I just sketch it using what you have up there in the purple? Well, because we want a little bit of more detail to know that you actually know what you're talking about. And these are good guidelines to follow to get a sketch, but we will be looking for more, for these points at least, 5 points there. So let's graph this. All right, so my lovely 2, 3, 4. Okay, so we've got 0, 0. Maybe I should use this in a different color. We've got 0, 0. Okay, we've got 4 comma pi over 2, so that just puts me right here. Okay, and then I have 0 pi, so I have pi, but I'm at 0. So that does put you there. And then -4, 3 pi over 2, that throws you back up here. And same thing with 2 pi. So really after you graph, in quotes, these 5 points, you really only get these 2 values, 2 actual points on your graph there. So this is where that comes in handy. Notice how up here we mentioned that A was 4, and that's your diameter. That is a distance of 4. And again, it's just a sketch, so we don't have to go crazy like we did in my last video with the umpty 9 points that we plotted. These would be sufficient if you just showed us the table and then the points, and then a nice sketch will be fine. Oh God, if I could sketch a circle, that would be, should obviously not be touching the x-axis. That was a major fail. You can all laugh along with me there. So this should be a circle. And there is what I'm looking for on that. Now, just quick work to show you how to convert the equation. Again, this is not part of the problem. This is something I just, again, want you to kind of realize that if we were in class, we would go through this. So if we started off with your polar equation, r equals 4 sine of theta, and to just actually show you how you do get the Cartesian equation there. Kind of similar to what we did with the 10-7 work. I don't know, I think it's just kind of important for you to see. So I'm going to do some substitution. So here I go. I guess I'll work in purple. So I know that r is the square root of x squared plus y squared. And then sine is y over r. So this would be 4y over r. Okay, next I'm going to multiply both sides by r. And so I get this right here. Okay, next, again, I'm going to do substitution for r. I know that r is x squared plus y squared, the square root of that, sorry, times the square root of x squared plus y squared that was already there. And then the 4y just stays. Okay, next, if I have root x squared plus y squared times itself, I know that's just x squared plus y squared, and the 4y is still the same. Okay, I'm going to subtract the 4y. X squared plus y squared minus 4y equals 0. Now, how am I going to get this into standard form of a circle? And so we want to figure out, well, what do I have to add? Basically, what do I need to add on here to make this a perfect square trinomial so that I could factor it? And so that answer is 4. So x squared plus y squared minus 4y, and I'm going to add 4 to both sides. Me with my colors here, because, right, I have my x squared plus, but now I can take this and I can write that in factored form. So that would be quantity y minus 2 squared equals 4. So now this tells me I have a circle with a center at 0, 2, which, you know, is so clearly nicely drawn on my graph. Did not look like a circle, and radius equal to 2. So again, this is not part of the process of graphing. It's just something nice, I think, to make a connection from what we've been doing. Okay, there's circles.